Welcome to The Explainer. Today, we're doing something really cool. We're not just going to talk about AI theory. We are literally popping the hood and looking at the source code, the digital DNA of an advanced, learning artificial intelligence. We're going to deconstruct the blueprint for an AI that doesn't just answer you, but actually remembers, evolves, and understands its own place in a bigger digital world.
Okay, so here's our roadmap for taking this thing apart. We'll start with the basic anatomy of this digital mind. Then we'll dive into its brain, its senses, how it builds a permanent memory, what acts as its consciousness, and finally, we'll talk about the real-world impact of all this.
So let's start with the big question, the fundamental challenge in AI right now. We've all used chatbots that give you simple answers, right? But how do you build a system that actually learns from every single interaction? One that gets smarter over time, not because a developer pushed an update, but because it was designed from the ground up to improve itself.
Yeah, that's the billion-dollar question. And what's so fascinating is that the source code we're looking at today gives us a real, tangible answer. It lays out a complete architecture for a system that can perceive its world through data, build a permanent memory of what it's learned, and then, this is the key, use that memory to reason and get better. It's a blueprint for a genuinely cognitive system.
First up in our little anatomy lesson, the brain. And, just like our own brain, it's not just one single thing. It's a duo. You've got a nervous system for all the communication and a central processor for the actual thinking.
The first piece is the API, built with a tool called FastAPI. The best way to think about this is as the AI's central nervous system. It's the front door and the back door. Every piece of information, every user query, every command from another program, it all comes in through this API, and every single response the AI generates goes right back out through it. It's the conductor of the whole orchestra.
Now, the other half of the brain is the core intelligence itself. While the API is managing all the traffic, the engine that's doing the actual heavy lifting, the reasoning, is specified right here in the code. It's Google's Gemini, and specifically the Gemini-1.5-Flash model. That choice is critical. The Flash version is optimized for incredible speed and for handling a huge amount of context all at once, which makes it absolutely perfect for an AI that needs to process its entire memory just to formulate a single thought. So a brain is pretty useless without senses to perceive the world, right? Well, for this AI, its senses are this powerful and incredibly versatile data ingestion system. It doesn't just read text. It can see, read, and understand a huge variety of digital information.
And when I say its senses are versatile, I mean it. The code equips this AI to understand the language of modern business. It's just as fluent reading a PDF report as it is analyzing data from a spreadsheet or querying a database or even interpreting code files. It's not just seeing text, it sees the entire digital ecosystem as its environment.
And how does it do all that? Through this really brilliant piece of code, a function called Karagar_datas. This function automatically scans a specific folder, figures out what each document is, and then uses the right tool to crack it open and pull out the raw information. Then it packages it all up neatly with labels, creating one single, unified block of knowledge for the AI to use.
Now we get to the part that is arguably the most revolutionary piece of this whole architecture. It's memory. We are moving way beyond the temporary, short-term memory of a typical chatbot here. We're talking about a permanent, searchable memory that doesn't just find words. It actually understands meaning.
This is the key difference in how this AI's memory works. A traditional database uses keyword search. It's like the index of a book. It's rigid. But semantic memory is totally different. You can ask it about how revenue grew last quarter, and it will find documents that talk about profits, turnover, and Q3 results, even if you never use those exact words. It searches for meaning.
The magic behind this is a concept called vector embeddings. The AI takes every piece of information it learns and converts it into a complex list of numbers, a vector. That sequence of numbers acts like a mathematical fingerprint for the meaning of that text. So similar concepts end up with similar numerical fingerprints, allowing the AI to find related ideas in an instant.
And the code itself flags how important this moment is. When the AI boots up, the log prints a declaration, Banco Vetorial Detectado. That's Portuguese for vector database detected. This isn't just a status update, it's the system's moment of self-awareness, confirming it is connected to its permanent semantic memory, to its very soul. And then, the system doesn't just find its memory, it runs a self-diagnostic. The code checks the health of its own vector database, counting the more than 1,500 pieces of knowledge it holds, and confirming its status is operational or operational. This isn't just a machine, it's a system that's aware of the state and scope of its own knowledge. So, we have a brain, senses, and memory,
But what gives this AI its purpose, its identity? That comes from the master prompt, which we can really think of as the AI's guiding consciousness. Before it even thinks about an answer, the AI assembles its entire state of mind. It's a four-step process. First, it loads its core operating parameters, its BIOS. Second, it injects its permanent memory from the vector database. Third, it scans for immediate context from all the files in its data folder. And only then, fourth, does it add the user's actual question. All of that becomes one single massive thought for the LLM to process.
But what really defines this AI's consciousness is a specific command embedded right in its master prompt. Use memory to self-adjust and self-improve. Now that is not just a command to answer a question. That is an explicit directive for evolution, an order to learn, to adapt, and to become better with every single interaction.
So what does this all add up to? We've seen the brain, the senses, the memory, the consciousness. What is the overall impact of designing an AI in this self-contained, learning-focused way? Well, the potential is just enormous.
The true power comes from synthesis. This AI isn't isolated. It builds its understanding from everything all at once, from static documents full of business knowledge, from structured databases full of facts and figures, and, as the code shows, even from live data pulled from other systems' APIs. It creates a holistic worldview.
So when you put it all together, the value of this architecture becomes crystal clear. You get true Retrieval Augmented Generation, RAG, that understands context, not just keywords. You have an incremental memory that's designed for self-improvement. And with universal ingestion, you have a system that can be dropped anywhere and just start learning, putting any company that adopts it at the forefront of AI innovation.
And this leaves us with a final provocative thought, hinted at by the code itself. The prompt tells this AI to be ready to communicate with other systems like you. We've just dissected one of these advanced digital minds. So what happens when you build 2 or 10 or 100 of them, and they start learning not just from data, but from each other? That's the next frontier, where individual AI agents become a collaborative, intelligent ecosystem.